welcome back to our YouTube channel. Today we'll discuss about the 18th National Certification Examination for Energy Manager and Energy Auditor. This exam was conducted on September 2017. Earlier we have already discussed the MCQ question answer of paper 2 for 19th and 20th National Certification Examination. And here we'll discuss the MCQ question of paper 2, which carries single marks. So let's start. In a heat exchanger with a high LMTD results in, options are higher heat transfer area, lower heat transfer area, higher U factor, none of the above. You see, larger the LMTD, more will be the heat transfer. Please remember this. Larger the LMTD, more will be the heat transfer. If more will be the heat transfer, then area required is less. So option B is the right answer. Lower heat transfer area required. Heat loss is equal to heat gain is the principle of, from this option, boiler, heat exchanger, steam traps. You see, heat exchanger is the right answer. Why? Because in heat exchanger, basically two fluids are used. One is a hot fluid, one is a cold fluid. One gaining the temperature, one losing the temperature. So heat loss is equal to heat gain. This principle is used in heat exchanger. Flash steam quantity per kg of condensate depends upon. Here, as I have already said in the earlier chapter, that flash steam quantity depends on the sensible heat and the latent heat of the condensate and the low pressure steam. So here the option C is the right answer, condensate pressure and the flash steam pressure. Which of the following waste heat recovery system is of thermal storage type? Option regenerative burner C is the right answer here. A boiler trial indicated 2% oxygen at boiler exit and 7% oxygen at stack. The in-leak air quantity between these two measurements is, you see, the formula we have to use here is oxygen out minus oxygen in divided by 21 minus oxygen out into 100. I repeat, the formula is oxygen out, that is 7%, minus oxygen in, that is 2%, divided by 21 minus oxygen out, that is 7%. So 7 minus 2 divided by 21 minus 7 into 100, the answer is 35.7%. So none of the answer is matching here. So none of the above, D is the right answer. The concentration of solids in a boiler is controlled by, you see, who's are working in the boiler operation. Whenever the concentration of the boiler drum or boiler water increases, the best thing we are doing, that is the continuous blowdown or intermittent blowdown. So blowdown is the right answer here to decrease the concentration of the solid of the boiler water. Insulating material made by blending and melting of alumina and silica is known as, the right answer is here A, that is ceramic fiber, because ceramic fiber is only made by melting and blending of alumina and silica. Now, tangential firing is used in which type of boiler? CFBC. It's circulating fluidized bed combustion, chain grate, spreader stroker, and pulverized fuel. Here option D is the right answer, because in PF boiler we are using the tangential firing, and that is called the corner firing also. You see, where the burner has a tilting mechanism, we can tilt the burner plus 30 degree, minus 30 degree. So option D is the right answer. This is required for the simple estimation of flame temperature of the fuel. The answer A, ultimate analysis, is the right answer here, because ultimate analysis is the elemental analysis. In this elemental analysis, we can able to know the percentage carbon, percentage oxygen, percentage sulfur, percentage nitrogen, which can help us to calculate the flame estimation, simple estimation of the flame temperature. Overall heat transfer coefficient in heat exchanger depends on Here all the options are right, so all of the above, D is the right answer, because the heat transfer coefficient of heat exchanger depends on conductivity of wall separating the two fluids, conductivity coefficient of hot and cold fluids, and fouling coefficient. Next, the key property of biomass fuel which influence storage, handling, and transportation. Basically, you see, storage, handling, and transportation. Here, for biomass, bulk density is the limitation. So because as the bulk density is more, we need more space to store it, and more handling cost and transportation cost also involved. So here the right answer is option C, bulk density. Which of the following contributes to spluttering of flame at burner tip? Here the answer should be water content, because water is responsible for spluttering flame. This question also repeated in 20th National Certification Examination. When 100 kg of fuel with 60% carbon is burnt with theoretical air, the mass of carbon dioxide release will be, here you see, carbon plus oxygen, it will give us carbon dioxide. So molecular weight of carbon is 12 and molecular weight of CO2 is 44. So 12 mole of carbon will give 44 moles of carbon dioxide. So 1 mole will give 3.67 mole of carbon dioxide. So zero point 0.6 will give 3.67 multiplied by 0.6, and 100 kg of carbon is here, fuel is here. So we have to multiply 3.67 multiply with 0.6 and again multiply with 100. The answer will be 220 kg. I again want to repeat. Carbon plus oxygen is equal to carbon dioxide. Molecular weight of carbon is 12. Molecular weight of carbon dioxide is 44. So 12 mole of carbon gives 44 moles of CO2. 1 mole will give 44 divided by 12, 3.67. 0.6 will give, again multiply by with 0.6, and 100 kg of fuel is here. So 3.67 multiplied by 0.6 multiplied by 100, it will give 220 kg. Which of the following heat recovery equipment works on the vapor compression cycle? This question again repeat, it's heat pump is the right answer. Which of the following releases large amount of heat per kg during combustion? You see, in combustion, here as per the option, hydrogen is the right answer, because hydrogen will give approximately 29,000 kilocalorie of heat, whereas carbon, sulfur and nitrogen gives lesser heat. Auxiliary power consumption for coal preparation will be highest in a which type of boiler? If you see from the option, pulverized coal fired boiler is the right answer, because in PF boiler basically the auxiliary power consumption is more, as we are using either the higher capacity of MDBAPs and basically the IDCTs. So hence the auxiliary power consumption is more in PF boiler. In a heat exchanger, for the same heat duty, higher the heat transfer coefficient, here option C is the right answer, because as I have already said, if the LMTD is more, then area required is less. So lower will be the heat transfer area needed. Answer C is the right answer. Which of the following increases when steam is passed through PRV? Options are specific volume, enthalpy of volume, sensible heat, and saturation temperature. Here the answer A is the right answer, that is the specific volume. Which of the following is not true with respect to improper sizing of coal? Results in poor combustion, lower excess air resulting in lesser stack loss, increases unburnt in ash, lower thermal efficiency. You see, in 19B is the right answer, because if we see here, improper sizing of coal leads to poor combustion. That's why we have to do the sizing of coal in the crusher. And you see, increase the unburnt in ash. This is also happening due to improper sizing of coal, and due to improper sizing, as there is no proper burning, so thermal efficiency also decreases. So option B is the right answer here. When solution of different concentration are separated by a semi-permeable membrane, water from less concentration solution passes through the membrane to dilute the liquid of higher concentration. This process is known as osmosis. Because in reverse osmosis, the reverse phenomenon will occur. The higher concentration liquid will flow to the lesser concentration area. Here option D is the right answer. Dash is used as heat carrier in thermic fluid heater. Please go through the book. Here option B is the right answer. This is the mineral oil. In thermic fluid heater, mineral oil is used to carry the heat. Dissolved CO2 in boiler feed water when left untreated would result in occurrence of dash in boiler tubes, because CO2 is responsible for corrosion. So B, water side corrosion, is the right answer. In a counterflow heat exchanger, cold fluid enters at 30 degree and leaves at 50 degree, whereas the hot fluid enters at 150 degree and leaves at 130 degree. The LMTD is. So if we draw this diagram, 150 degree to 130 and cold fluid 30 degree to 50 degree, then we see here the TTD, that is the terminal temperature difference, will be 100 in one side and another side also it is 100. So if the terminal temperature difference is same in both the side, then basically as per the formula the answer will be 0. But the LMTD cannot be 0. So here LMTD is equal to the TTD, that is terminal temperature difference, that is 100 degrees, the right answer. Which of the following is not measured in a ultimate analysis of a fuel? So which of the following is not measured in ultimate analysis of fuel? In ultimate analysis is the element analysis. So oxygen, fixed carbon, sulfur, nitrogen. So here the answer should be answer B, because in elemental analysis we can calculate oxygen, sulfur and nitrogen, but fixed carbon can be calculated by proximate analysis. Ceramic fiber gives the maximum energy saving when used in, you see the answer is batch furnace here. Please go through the book, types of furnaces, and here you can see in the batch furnace ceramic fiber gives the maximum energy saving. In industrial application, the common used trap for main streamline is, this question also repeat here, thermodynamic traps are used in the industrial sectors, power plants basically. Fluidizing bad combustion takes place in the temperature range of, answer should be here 800 to 900 degrees centigrade, because higher is the temperature, there is a chance of clinker formation. So 800 to 900 degrees centigrade is the right answer. In a glass industry, waste heat is used for power generation. This type of cogeneration is called, the answer is bottoming cycle here, because in the earlier chapter I have already discussed what is topping cycle, what is combined cycle, what is bottom cycle. So when the waste heat is directly used for power generation, the cycle is known as bottoming cycle. So answer B is the right answer here. Select the odd one among the following: condenser, distillation column, evaporator and cooling water. You see A, B, C, both options all are closed cycle and cooling tower is open cycle. So cooling tower is the right answer here. In a boiler, air preheater is installed. If you are working in a power plant, basically you know it is after economizer. So option C is the right answer. A pinch analysis can result in, basically pinch analysis is used to for the reduction in cooling water and reduction in steam as well. So option D is the right answer here. The main contributor for temporary hardness in boiler water. So it's temporary hardness. We know there are two types of hardness, permanent and temporary. Temporary hardness is normally due to the bicarbonates of calcium and magnesium. So option C is the right answer. The amount of oxygen required to burn 0.5 kg of sulfur. If you see the formula, sulfur plus oxygen is equal to SO2. The molecular weight of sulfur is 32 and molecular weight of oxygen is also 32. So 1 mole of sulfur is required for 1 mole of oxygen. So if 0.5 kg of sulfur is given here, then the answer is 0.5 also. This is required to accommodate expansion of steam pipe, PRB, expansion loop, steam trap, air vent. The result is expansion loop. Why? You have seen in steam pipes, we have given some expansion loops for taking the expansion of the boiler. Steam main should be run with a falling slope of dash in a direction of steam flow for effective line condensate drainage. So as per IBR, if you see, option B is the right answer, because in every 30 meter we have to keep 125 mm slope. So option B is the right answer. Degassure in water treatment is used to remove. Degassure basically used after strong acid cation. It is used to remove the CO2. So in 30, so here you see the answer is carbonic acid, B, because in the DM plant, if you see, after the filters, the first stage we are using strong acid cation. In this cation, basically the cation are the positive ions which are the heavier in nature. The removal of cation will be done by the resin R minus H plus, and the water is slightly acidic in nature here, and the formation of carbon dioxide also here. So after strong acid cation, we have to use a degasser to remove the carbonic acid, and after that we have to use the anion exchanger. So answer B, carbonic acid, is the right answer here. In a boiler, theoretical air to fuel ratio is 15:1. If 10% excess air is supplied, flue gas to fuel ratio will be, you see here, the theoretical air is 15:1. Excess air is 10%. So the formula is 1 plus excess air multiplied by theoretical air will give the actual air. So 1.1 multiplied with 15, it is 16.5:1 is the actual air to fuel ratio. Then again, it is flue gas to fuel ratio. So flue gas is again 1.1 multiplied by with 16.5, it will give you 18:1. So here from the option 17.5:1 is the right answer, which approach just closer to the 18. So option B is the right answer. Increased sulfur percentage in furnace will, here option A is the right answer, set lower flue gas temperature exit, because if temperature will be higher, then it may reach sulfur dew point where there is a chance of sulfuric acid formation. So it sets lower flue gas temperature limit. So option A is the right answer. Which among the following is most viscous fuel? From the option A is the right answer, furnace oil. As you know, in the power plant, we have to heat the furnace oil before atomizing it in the boiler furnace. So option A is the right answer here. The turbine heat rate is expressed as, it is kilocalorie per kilowatt hour. So option A is the right, sorry, option C is the right answer, kilocalorie per kilowatt hour. Basically heat rate is inversely proportional to the efficiency. through opening in furnace is directly proportional to, basically through opening of furnace is the radiation loss. So in radiation loss, we know the heat loss is directly proportional to the fourth power of the temperature. So option D is the right answer here, fourth power of absolute furnace temperature. Which of the following is an example of basic refractory? I have already discussed in the earlier chapter. So here the options are aluminosilicate, chrome, magnesite and pure alumina. So refractory are of three types basically: acidic refractory, basic refractory and natural refractory, neutral refractory. So here the option C is the right answer because magnesite are in the basic refractory. Which property of the refractory determines the deformation under stress? Here the option A is the right answer, creep. In creep, basically the refractory determines the deformation under stress. ESP, electrostatic precipitator in FBC, fluidized bed combustion boiler, is used for the removal of fly ash. So option B is the right answer because bottom ash removal is in the bottom ash hopper in the furnace area, and SO2 removal can be possible by FGD, by installation of FGD. So fly ash removal is the right answer. Heat rate is likely to be least for, and this option B is the right answer because in condensing turbine there is huge loss, that's why the heat rate is also less. B is the right answer. Which of the following is true of plate heat exchanger? Here the options are close approach, expandable area, countercurrent. So all the above options are right. So option D is the right answer. In FBC, that is fluidized bed combustion boiler, fluidization depends largely on particle size, air velocity, bed material or size of the boiler. So basically it's depend upon particle size and air velocity. So option C, that is particle size and air velocity, is the right answer. When the boiler bed temperature exceeds beyond 950 degree, the result is, we have already discussed this in the earlier chapter so many times, there is a chance of clinker formation. So option B is the right answer, and also there is a chance of NOx formation due to high temperature combustion. Now we see automatic blowdown control for boilers work by sensing. So we do the blowdown to decrease the concentration of the boiler water. So here if we install automatic blowdown, it senses the conductivity as well as the pH. So option D is the right answer, and after sensing the conductivity and pH, it starts blowdown. Latent heat of steam at the critical point, as we all know, it's 0. So option C is the right answer. So it's all about the MCQ question answer of 18th National Certification Examination. We'll again discuss some more in the relevant next sessions. So have a nice day. Bye-bye.